Hey everyone, in this video I want to talk about managed disk resize and the live resize capability. As always, this is useful. A like, subscribe, comment and share really is appreciated, and hit the bell icon to get notified of new content. Now, managed disk is this fantastic capability that I can use with VMs, virtual machine scale sets, Azure Kubernetes service and other types of service that abstracts the underlying storage account. I can think I get this first class Azure resource. So I have some managed disk. And behind the scenes, what actually happens is there's still a storage account. So there's some storage account that I don't really see. And in there, it creates a page blob. So I get this idea of a page blob. But it abstracts it away. So I don't have to worry about limits of the storage account, be it capacity or throughput or anything else. I just see this great managed disk that I can then use for these other types of service. Now, just like all other types of storage service, there's always 3 copies of the data. They might be in the same data center, LRS. They might be spread over availability zones, ZRS, zone redundant storage. There is no GRS option with managed disks. Typically an asynchronous type replication, which is what you have to do between regions. That's something that's better served within the OS, where it understands what's happening with the volumes, or at the application level. Things like Azure Site Recovery could do that cross-region replication of disks from within the operating system. But because this managed disk is a native Azure resource now, I get capabilities like role-based access control. I get the ability to have things like images. I have snapshots. We also do have those different resiliency options around availability set alignment and availability zones. And there are different encryption options, either at the storage level through disk encryption sets, where I can even bring my own key, or within the operating system using Azure Disk Encryption, which uses things like BitLocker or dmcrypt if it's Linux. There are different types of managed disks depending on the performance, the latency I want. You see things around standard hard disk drive, SSD, premium SSD, and ultra disk. So we have different types, and they have different performance characteristics. But typically what you're going to see is the performance will scale linearly as the capacity increases. And we're going to come back to that. Now, when I create a virtual machine, at minimum, typically it's going to have an operating system disk, unless it's using ephemeral storage, where it uses the temporary or the cache area of the host that's running the VM. But they're very specific circumstances. But typically, hey, I'm going to have at least an operating system disk, which is a managed disk. And that would be the size of whatever image I use to create my virtual machine. Linux, a lot of times this is maybe 30 gigabytes or 10 gigabytes. Windows, historically, it was 127 gigabytes, but there were smaller images available. But that will be the starting size of my OS disk, unless I specify a bigger number as part of that actual provisioning. So the OS disk is going to be the size of the image unless I specify a bigger number. Now, what I can also then do, so if I think about this for a second, hey, I have some VM, and typically I have that OS managed disk, and optionally I can add additional disks. I can add multiple data disks to that virtual machine, and I can hot add and hot remove those. I don't have to deprovision the VM. I can add and remove them as I see fit, depending on what the application's doing, if it's actually using that volume. Now, the number of data disks I can add and remove varies. If I go and look, for example, at the different virtual machine SKUs, it will tell you. So just like most other aspects of a resource, as the resource gets bigger, its scale increases across all of the different dimensions. So what I mean by that is, if I look, I can see here a column, max data disks. So as the VM gets bigger, CPUs, memory, temp storage, it supports more and more data disks attached to it. Now you also have to look out for criteria such as, well, what's the total IOPS and throughput supported by the virtual machine when I think about the overall performance. But as the VM gets bigger, typically I can add additional data disks to that virtual machine. So I can add these. So what I would do is I pick a certain size and a certain type of disk. Remember, standard hard disk drive, standard SSD, premium SSD, or ultra disk. So I pick a capacity. Now with that capacity, so I can think about capacity, there's also IOPS and throughput. And as I get a bigger disk, I get bigger IOPS and bigger throughput. So when I'm picking the size of my disk, I might pick a certain size because I need the capacity, or I pick a certain size, not because of the amount of data I need to store in it, but I need the associated IOPS or throughput, or both, that's associated with the given capacity of the disk. Now this is where the resize can come in really useful. Maybe initially I only need a certain capacity, or I only need a certain IOPS and or throughput. So I can start with a smaller disk. We pay for the provisioned size. We don't pay for the amount of data written to manage disks. We pay for the provisioned size of the disk. This is what we pay the money for. So if I create an 8 GB disk, if I write 20 kilobytes to it, I'm still paying for an 8 GB disk. So I could start off with a smaller disk, and then as needed, I could increase the size of the disk. I can only increase the size. So I can resize up. I cannot shrink. Cannot. So I cannot make a disk smaller. I can take a disk and I can increase it, make it a bigger disk, but I can never shrink it. If you think logistically, shrinking a disk is actually very difficult. There's volumes getting created on those disks inside the operating system. Data may not be written very neatly starting at the start of the page blob. It could be scattered all around. So actually trying to shrink a disk is super difficult. Invariably, I'm probably going to get data loss. So if I actually did at some point need to shrink a disk, well, I'd have to create a new disk and then copy the data to the new, smaller disk. That's really the only way I could shrink a disk. I create a new one, copy the stuff, and then delete the old one. But I can resize upwards. That lets me start with that smaller disk and increase it as I need more capacity, or I need additional IOPS, additional throughput. So I want to take just a second to focus on that point. So before you start jumping to resizing and making a disk bigger, think about why. Why am I making the disk bigger? Now, an obvious one might be capacity. Now, if you're making it bigger for capacity and it's a long term, hey, it's just going to keep getting bigger and bigger, yes, resizing upwards a disk may make total sense and is probably the right thing to do. If I have a temporary need for a bigger disk, maybe for a week or a month, and then that need will go away, I probably don't want to resize it upwards. I would be better off adding an additional data disk that I could then remove and delete at a later point, because I cannot shrink it and I pay for the provision size. So if I increase my disk and make it bigger, and then in a week or a month, I don't need that additional size, I'm still stuck paying for it, as I want to go through some super painful exercise of copying all the data. So even if it's capacity, is it long-term or short-term? Long-term, yes, resize the disk. Short-term, maybe it's better to add an additional disk. Now, what about if it's performance? It's IOPS or throughput or both of them. Now, yes, as I increase the capacity of the disk, my IOPS and my throughput increase as well. But once again, is this a long-term performance need? What is the characteristics of that performance? Is it little bursts? Is it short term? Is it long term? Because there are different capabilities. For example, if I look at standard SSDs and premium SSDs, they actually have a burst capability. If we go and look for a second, so let's just jump over, and what we can do is if we were to actually go and create disks, if I just do create for a second, and I'll just change the size, look at some of the characteristics. So this is a premium SSD. So on the premium SSD, notice you have, yes, that provisioned amount of IOPS and provisioned amount of throughput that goes up as the disk gets bigger. But you also have this burst capability. So if this bursting for up to 30 minutes, if I've accrued some credit, i.e. I've used less than the provisioned amount, I can exceed that. Now remember also the VM or whatever is attached to that has to have that throughput performance as well, but that may be enough. That might be the right option for me. Now also realize that only applies to kind of this up to a P20, up to 512 gigabytes. Now over that, there's actually something called on-demand bursting. That's something you pay for. It has to be enabled, but I can do that as well. And notice if I change it to standard SSD, I have the same burst capabilities available to me. I don't have that with standard hard disk drives. UltraDisk, well, UltraDisk actually separately considers capacity, IOPS, and throughput. I have different dials and I pay for each of the capacity, IOPS, and throughput I use, and I can actually change IOPS and throughput live at any time I want. So UltraDisk separates out those three dimensions of the disk so I can change these when I want. So I've got burst capabilities. I can change them. Short term, hey, I need increased performance, maybe for longer than I can do for burst. Well, once again, if we look at premium disks for a second, a feature of premium disks is I actually have the option of a performance tier. So based on the size, hey, I pick 128 gigabytes, a P10, I could select a higher performance tier. So I'll get the capacity of 128 gigabytes, but I'll get the performance of the bigger disk. Now I'll pay for the bigger disk, but the disk itself is only that size. And then every 12 hours, you can decrease that. So the benefit there is, hey, if I needed bigger performance for a fairly short amount of time, maybe a few hours, hey, rather than resizing the disk that, remember, I cannot reverse, I can change the performance tier of the premium SSD to a higher one. I pay them more money, but then I can reduce it back to the performance I need longer term. So there's always these different options. So before you leap to resizing a disk, make sure you really understand, why am I resizing it? Is it the capacity? Is it short or long term? Short, maybe better to add an additional disk. If it's performance, understand the characteristics of actually what we want to do. But let's assume we've looked at those. And yes, it's long term. I want to resize my disk. So we can resize upwards. We can make managed disks bigger. Now I can do this for Windows and Linux. I can do this for the OS and data disks. But traditionally, we have to do this offline. I have to deprovision the virtual machine that the disk is connected to. Then I can resize the disk, and then I start it again. Now, technically, because I can hot add and remove data disks, I don't have to deprovision the VM. I could detach the data disk, resize it, and then attach it again. But if it's a data disk, the app's probably using it, so that may not be that much of a useful option. So all types of disk, standard HDD, SSD, premium SSD, UltraDisk, can all be offline resized upwards. But now what I can do is I can do a live resize of the standard hard disk drive, SSD, and premium SSD. I cannot do it for UltraDisk today. But it's still increase. There's no scenario where I can shrink the disk. It is data disks only. So now these, I can do a live resize. Again, I can make them bigger. Not for the operating system today. Again, all types except Ultra Disk. And there is a size boundary. So if I think about all the different types of disk I could create, if we actually jump back for a second, hey, look, there's disks all the way up to 32 gigabytes. And you'll notice, so that's, 32 tebibytes. That's 32,000 gigabytes. And I'm saying gibby and tebi because it's 2 to the power of something. A terabyte and a gigabyte is actually 10 to the power of something. It's not technically accurate. So you'll notice they always say this GIB and TIB. So I can go up to 32 tebibytes, which is 2 to the power of. That's why. So I can create these huge disks. And so I can start with a smaller disk and I can resize up. But the live resize, there's a line. I can think about a line of 4 tebibytes. So I can increase the size up to 4 tebibytes live if I'm currently under 4 tebibytes. And if I'm over 4 terabytes, then I can increase it up to whatever I want to do. But if I try and change over, if I try and cross the line, so if I'm below 4 terabytes and I try and go above 4 terabytes, then it has to be an offline. I have to detach the disk or deprovision the virtual machine. Because there are some things that are different under the hood. When I'm resizing here, what's actually happening is, let's kind of draw another one. So when I'm doing a resize over here, I start with a certain size page blob, and I do a live resize of the appropriate managed disk. As I'm making it bigger, it's actually just increasing the size of the page blob that's associated with that managed disk behind the scenes that's abstracted from us. But it can only do that up to 4 tebibytes. Once you get past 4 tebibytes, it has to do some different things behind the scenes in terms of the capacity, because there's a maximum size of a page blob, and also giving you the performance you need. So as soon as I try and cross over the line, that has to be an offline. Now, once I'm past the line, then I can continue doing that live resize of my data disks. But if I try and cross the line, that has to be an offline. And we can actually see this. So what I want to do now is show you some of these things. Now I'm going to do some unnecessary steps just to kind of prove the point that it's just resizing that back-end page blob behind the scenes. And then we'll see that when we cross the line, it's actually gone and done something different. This is in preview today. You have to register, and the link's in the description below how to register for that. There's a special version of the portal today that again is in the documentation. But I'm going to walk through and hot add a disk. We'll see it. We'll look at an access signature to see the underlying storage account and the actual blob. Then we'll reattach it. We'll resize it live. We'll check that blob hasn't changed. And we're going to keep kind of pushing that so we can see all of this in action. But the key point for you is with this functionality, I can now take data disks and I can live resize them without having to stop the VM or detach the disk. I just can't cross the 4 tebibyte boundary live. So I can resize up to the 4 tebibytes if I'm below it. If I'm already above 4 tebibytes, I can live resize, but I just can't cross that little boundary. So let's see this. So what I have is a virtual machine. So right now, if we go and look, I created this little demo VM resize. And right now, I don't have any data disks attached to it. If we go and look at the virtual machine, you can see, hey, I just have my operating system disk. And then we get the temporary drive that we get with most virtual machines. So I have no data drives right now. But we can hot add. So I'm going to say, hey, I want to create and attach a new disk. I'll call it data 1. And I'm cheap. I'm going to say standard SSD. And sure, we'll say 4 gigabytes. And I'll say save. So it's going to create the disk, and it's now going to go and attach it to the virtual machine. Now, when we live add disks, we've noticed it's now shown up, but it's offline. I'll have to online the disk, and then I'll have to initialize the disk. And then once it's initialized, hey, I'll have to create a volume on it. So I'll go and create a volume. We always want to do a quick format. And now I'll have that disk. So now I've got my new volume, and it's E. So if I actually went and looked at that for a second, let's go and look, File Explorer. We could just drop a file to kind of prove that we're not losing any data. So I'm going to do a new text document, test. Here I am. Now Linux is obviously a slightly different thing to mount the drive, partition, etc. But same, I can hot add and remove the disks. Now at this point, before I actually do anything else, I actually want to prove a point. I want to go and look at what is the underlying actual blob and storage account. So remember I said it was abstracted away. So what I'm going to do is I'm actually going to offline that disk just to cleanly do that. And then in the portal, I'm just going to quickly remove it. Now, the reason I have to do this is the VM creates a lease on the blob, and that lease stops me doing some other functions that I want to do. So now what I'm going to do is, now that lease is gone, I'm going to get a shared access signature to the disk and just look at it. And that will show me the storage account and the page blob. And I only care about this to show you when I do the resize, the page blob hasn't changed underneath. So it takes just a second to go and get this shared access signature, and then we can look at it. And all I'm going to do is compare it after I do the resize. Now, once I get this shared access signature, I have to revoke the access, or I can't reattach the disk to the virtual machine. Okay, so now I can look at the shared access signature, and I'll do the revoke. So what we care about here is this. This is showing us the storage account. And then, well, A, B, C, D, basically. So I'm just caring about those items there. So then it's going to go and revoke that to release the lease so I can go and reattach it to my virtual machine. So I just need to let that finish, and then I can carry on. So that's released. Now let's add it back to the virtual machine. So I'm going to attach an existing disk. There it is. And save. So it's updating the virtual machine. And what I'll see is, there you go, it's popped back. I can online it. And there it is. So it's just back to that original size. So now what we're going to do is the cool part. I'm going to select the disk, size and performance, and I'm going to change it to 8 GB and hit resize. And that's updating the disk. Now what I'll see is, right now, remember it's that 4 basically gigabytes that I see of the disk. Now it can take different amounts of time, and you can see the job running now to update the disk. But once it's completed within the operating system, suddenly that disk has got bigger. Now remember, just because the disk is bigger doesn't mean there's anything I'm using within that disk. Either I'd have to go and create a new volume on the disk, or I would extend the current volume, which is what I'm going to do. Now the exact process for that does vary. I'm going to show it to you for Windows. It's in the documentation for Linux. So it goes through exactly what the process would be. It talks about all the commands I would have to run inside the Linux box to actually then go and expand the partitions to use the new amount of size and resize the file system to actually see that new capacity. And again, this link is in the description below. So it's going through and it's doing that increase of the page blob. So we need this to finish, but the VM is still running, remember. I'm still on the VM, I'm still could be writing things to the disk. If we go and look again at our File Explorer, we'll see we've still got our file there. So there's our file. We're still looking good. So let's jump back. Okay, so that disk is successfully resized. So now if we jump back over, it would catch up eventually if I don't do anything. So I could just leave this and at a certain point, this will detect, but I can also just go and force it. So if I do action oh, we did it even before I clicked it, but I could have done action refresh. Notice now it says unallocated. So now to actually use that bigger disk, I would have to go and extend the volume, tell it how much additional space to use. So now it's extended the volume within the operating system. And my file is still there. Nothing has changed. So I've dynamically increased the size. Now what I'm going to quickly do is let's offline this disk. And now with it offlined, what I can do is detach it. I want to do it neatly. I don't just want to detach it. I'd rather within the OS offline or in the next, I'll mount it first. So I want to disconnect it because I want to look at that shared access signature. So it's updated the virtual machine. So now I should be able to go back again and get a new access to the disk because the lease from the VM is gone because I detached the disk. And I want to look at it again. And what we're looking for is it should be the same start of the access signature because it's the same storage account and it's the same blob. So we're going to go and get that new access to it and then we'll look at it. And this would apply, remember, all the way up to that 4 tebibytes because at that point it can just keep expanding the page blob. Once I want to cross 4 tebibytes, which I will show you, we'll actually see it's going to be a new one. So now if we look again, so here, remember, this was the original MD, blah, 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 all of that stuff. And then, so if we scroll up, scroll down, there we go. They're the same. It has not changed. So the page blob itself is exactly the same page blob. It has expanded the page blob as I performed the resize. So now what I'm going to do is attach the disk back again. And we can resize it again. And what we'll see is I can resize it all the way up to that 4 tebibytes. So let's update the virtual machine. So now it's showing us offline again. I'll online it. Let's do another resize. And we'll push it to what we're allowed to do. So this time I'm going to push it all the way up to 4 and hit resize. And it can do this live. And it's the same. I'm not going to detach it and show you again, but it's the same blob underneath. But if I try and push it beyond, it will actually fail. It will say, look, I need to move it and I can't because it's actively being used by something. At that point, I have to either shut down this VM or detach it. So what I'll do is I'll show you the detach just so we can actually see that underlying storage account does change when I try and cross the line of that 4 tebibytes. It's just a kind of a little bit of fun, but we can see that actually flow through. Now that resize is completed. If we go back inside the OS again, it's not called up. Let's try and beat it this time. So we'll do refresh. And now we see this huge amount of unallocated space. So once again, I would go and, okay, I need to extend the volume. Use all that additional space, and now I'll get this much, much bigger volume inside the guest. So I always have to go and use that new space. But once again, on my file is fine. So I've not had to actually detach the disk at all as part of the resize. The only reason I've detached it was to show you the fact that the storage account hadn't changed, but there was no need to attach it. All of my resizes were done live while it was attached to the virtual machine. So now let's try and cross that 4 tebibyte boundary. So I'm going to go to 8 tebibytes, resize, and it's failing. So it's failing because it needs to be moved, but the blob has a lease. So this is showing me, hey, look, when I cross that line, it has to work in a different way. So what we'll do now is we'll detach it so I can show you that. So I'm going to detach the disk. Well, what I really should do is make sure, again, be neat and tidy, offline it first. Whatever the OS, Linux has its own process around that. Save to detach the disk. And what I'll now be able to do is I will be able to resize it. Once it's detached, or again, I could have just deprovisioned the virtual machine, doing the same thing. Now if I go and look at the disk directly, and now I can change it to 8, resize. And now it will work, successfully updated the disk. So let's look at it. So remember, if I now go and get a new link for shared access signature to that disk, remember this is what it was for all of the previous times. What I would now expect to see is it's going to be something different because it's had to move it because now we're crossing that line of 4 terabytes and it has to do different things under the hood, both from a capacity and to meet the various performance things. So it's doing a different underlying mechanism. So we should now see a different storage account and page blob as part of that. So now we can go and look at the signature again. And yeah, sure enough, it's changed. So if we look, notice it was this VSMBWN. Well, now it's BG1. It's changed. It's in a new storage account. It has been moved to cross that 4 terabyte boundary. Now at this point, I can reattach it to the virtual machine. And at this point, I could now keep on live resizing it. So now I can go back to my virtual machine. I can go and re-add the disk. Let me just make sure before I do that, this revoke access has completed. Otherwise, this will be a lease on it and it wouldn't let me attach it to the virtual machine. So I need to make sure that that completes. Now I can hit save. So it's adding that back into the virtual machine. And so now within the VM, notice it's increased in size. I now have this unallocated blob. So once again, I'd have to online it. Once again, I would do my extend volume to use all that additional space. And now I've crossed that line. And now because I've crossed that 4 terabyte boundary, I can now keep increasing the size. My file is still there. My super important file has not been lost. It's still sitting there. And at this point, now it's using the new mechanism for the storage. Hey, yeah, I can go and increase it again. So now I'll try and resize it. Thinking. So I've crossed that line, so now I can do those live resizes. So we saw that just successfully updated. Now back inside the OS. Again, it would pick up eventually, but I'm impatient. Oh, there we go. Refresh. I would increase the volume again, etc., etc. But that kind of really demonstrates that whole live resize process. So that was it. That was really the goal of the video. Really wanted to now stress the point that we can do that live resize for our data disks, standard hard disk drives, standard SSD, premium SSD. We now have that live resize capability. Remember, once we've done that, once we increase the size of the disk, then within the OS, we have to then obviously increase the size of any file systems, volumes, partitions, etc. we have as well. Make sure you consider why you're increasing it. Short term, long term, hey, is it performance? Because the key point is I cannot shrink it. So I don't want to get myself into a position where I increase the size. I'm like, oh, I wish I hadn't done that, because now I want to bring the size back down. Think about, is it capacity? Is it performance? What are my options? Burst, maybe premium SSD. I can do those shorter term, just raises a performance level and then shrink it back down again. Make sure you think of all the different options available to you. But that was it. Now I can start with a smaller disk and I can grow it without any interruption for those data drives. At the time of recording, it is in preview, but keep an eye on it and you'll see this kind of go to other regions and then go GA. As always, there's a lot of work goes into preparing these out, so a subscribe is appreciated. But until the next video, take care.